Hello students, today we will learn about the Raoult's law for liquid mixtures. Before going directly into the statement, let us consider if at all we mix two liquids, what happens. Red color let it be A and green color let it be B. If at all we take it in a closed container, A is volatile, so from liquid it gets into the vapor phase. So A molecules will be present in the liquid phase as well as in the vapor phase. Slowly the vapor molecules will go on increasing because of more vaporization of A as the time proceeds. Finally, some of the A molecules they again come back from vapor phase to liquid phase. So also we find B molecules represented by green in the vapor phase as well as in the liquid phase. So we find for both A as well as B, the rate of evaporation, that is from liquid to vapor phase, and rate of condensation from vapor phase to liquid phase conversion will be at equilibrium. They will be one and the same. So under that equilibrium condition, we find both A molecules as well as B molecules in the vapor phase as well as in liquid phase. The concentration of A can be represented by mole fraction. In the liquid phase, the mole fraction of A is represented as XA and that of the B is represented as XB. Similarly, we find A as well as B in the vapor phase. The mole fraction of A in the vapor phase is represented as YA and mole fraction of B in the vapor phase is represented as YB. The vapor will exert the pressure over the solution. The pressure only due to A is partial pressure of A and the pressure due to only B molecules is partial pressure of B. So XA, XB are the mole fractions of A and B in the solution. YA and YB are mole fractions of A and B in the vapor phase. PA and PB are the partial vapor pressures of A and B in the solution. If at all we consider a container in which we are going to consider only A molecules. So again this liquid A molecules they get evaporated and again they condense back. So it is in the pure form, there is no B. So under the equilibrium condition it exerts the molecules, they exert the pressure over the surface of the liquid, that is represented as P naught A. Similarly, instead of the A, if at all we take a liquid B in another container, the vapor pressure of B in its pure form is P naught B. We assume that B molecules will evaporate more compared to that of A. Andre, we find more amount of the B in the vapor phase compared to A. So that the partial vapor pressure of A is always less than partial vapor pressure of B. Only ನಮ್ಮ ಕನ್ವೀನಿಯನ್ಸ್ಗೆ ನಾವು ಇದನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. Okay, so now we are going to see vapor pressure of liquid solution. Consider a solution containing two volatile components A and B in a closed container. The equilibrium is established between the vapor phase and the liquid phase at constant temperature. Let P total, the total pressure of the solution, PA, PB be the partial vapor pressure of A and B, XA, XB are the mole fractions of A and B in the solution, YA and YB are the mole fractions of A and B in the vapor phase. Now we will discuss the Raoult's law for a solution of volatile liquids. Generally, statement will be asked for 1 mark and problems based on it will be asked for 2 marks. Even in CET also you can expect the problems based on Raoult's law for a solution of volatile liquids. So what is the statement? The partial vapor pressure of each component of a solution is directly proportional to its mole fraction in the solution. So we are considering two components A and B. For the component A, it says that partial vapor pressure PA is proportional to XA, its mole fraction in the solution. Or we can remove the proportionality sign. PA is equal to XA into proportionality constant P naught A ಅಂತ ಬರೀತೀವಿ, where P naught A is the vapor pressure of the pure component A at the same temperature. So similarly, for component B, we can write, so PB is proportional to XB ಅಂತ ಬರಿಬೋದು. Or we can write PB is equal to P naught B into XB. Here P naught B is the vapor pressure of pure component B ಅಂತ ಬರೀತೀವಿ. So we know that according to last year ಕಲ್ತಿದ್ದದ Dalton's law of partial vapor pressure, it says that the total pressure over the solution phase in the container will be sum of the partial vapor pressures of all the components of the solution. So P total should be equal to partial pressure of all the components. Illirodi erade component A and B. So PA plus PB. So according to this the Raoult's law, we say that PA is equal to P naught A into XA, PB is equal to P naught B into XB. ಅದನ್ನೇ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ. P naught A into XA plus P naught B into XB. So again we know that sum of the mole fractions of all the components in the solution is always equal to 1. Thereby XA should be equal to 1 minus XB. So P naught A ಇಲ್ಲಿ XA ಬದಲು ಏನು ಬರಿಬೋದು ನಾನು ಇಲ್ಲಿ 1 minus XB plus P naught B. So if we take XB out, then P naught A plus ಇಲ್ಲಿ P naught B ಬರುತ್ತದೆ minus P naught A into XA ಅಂದರೆ I can write P naught A into XB. Look here. So P total is equal to, we can write P naught A into XA plus P naught B into XB. ಇದನ್ನು total pressure find out ಮಾಡಲಿಕ್ಕೆ we should know the four things: P naught A, P naught B, XA and XB. ಇಲ್ಲಿ ನೋಡಿದರೆ, so even if we don't know this XA, still we can calculate the total pressure if we know the vapor pressures of A and B and mole fraction of one of the component XB. ಹೌದಿಲ್ಲ? ಸೊ ಇಲ್ಲಿ ನಿಮ್ಗೆ CET ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಿದ್ರೆ ದೀಸ್ ಇಕ್ವೇಷನ್ಸ್ ವಿಲ್ ಬಿ ಹೆಲ್ಪ್ಫುಲ್ ಟು ಯು. ಈಗ ನಿಮ್ಗೆ ಒಂದೇ ಗೊತ್ತಿತ್ತು ಅಂದರೆ ವೆಲ್ ಆ್ಯಂಡ್ ಗುಡ್, ಇಲ್ಲಿ ನೀವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೋಬೋದು. ಇಲ್ಲಪ್ಪ ಇದನ್ನೇ ಇಕ್ವೇಷನ್ ನೀವು ನೆನಪಿಟ್ಕೊಳ್ತೀನಿ ಅಂದರೆ ದ್ಯಾಟ್ಸ್ ಆಲ್ಸೋ ಫೈನ್. ಸಿಮಿಲರ್ಲಿ ಇಲ್ಲಿ ನಾವು XB ಅಲ್ಲಿ ಹೇಳಿದ್ವಿ. Now we can express it in terms of XA. P total should be equal to P naught A minus P naught B into XA plus P naught B. So from these equations, what is clear? The total pressure over the solution can be related to mole fraction of any one of the component, either XA or XB. This is one thing. Depending upon the vapor pressure of pure components A and B, total pressure of the solution decreases or increases with increase in mole fraction of the component A. Now either the mole fraction ಜಾಸ್ತಿ ಮಾಡಿದರೆ we can see that the total pressure can increase or decrease. Whenever we are going to solve the problem, that will be clear. Total vapor pressure over the solution varies linearly with mole fraction of the component B or A. So if at all we draw the graph of vapor pressure against the mole fraction, we find that the graph will always include straight line. Illi nodri, we are going to draw the graph of vapor pressure along the y-axis, mole fraction along the x-axis. Illi now one container ತಗೊಳ್ತೀವಿ, ಇದರಲ್ಲಿ only A component will be there, okay, so that there is no B. So XB should be equal to 0 and XA ಏನು ಗೊತ್ತಿದೆ ನಮಗೆ, XA plus XB is equal to 1. So XB is 0, thereby XA is equal to 1. ಹೌದಾ? ಅದೇ ಥರ ಇಲ್ಲಿ ಬಂದರೆ in this container it contains only the component B, there is no A, so that the mole fraction of A is equal to 0, XB is equal to 1. Whatever the pressure exerted, that is only due to B. So this is in the pure form, thereby this point represents P naught B. This point represents P naught B. ಇಲ್ಲಿ A ಒಂದೇ ಇದೆ, thereby whatever the vapor pressure exerted is due to A only in its pure form. Pure ಇರೋದಕ್ಕೆ P naught ಅಂತ ತಗೊಳ್ತೀವಿ. Here we are going to consider A is less volatile than B or B is more volatile. It gets easily evaporated ಅಂತ ತಗೊಳ್ತೀವಿ. Now we are going to see the partial vapor pressure, how they change. Okay, so ಇಲ್ಲಿ ನೋಡ್ರಿ ಈ ಥರ ನಮ್ಗೆ ಗ್ರಾಫ್ ಬರ್ತದೆ. ಇಟ್ ಈಸ್ ಡ್ಯೂ ಟು ಪಾರ್ಷಿಯಲ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ಬಿ. ಇಲ್ಲಿ 0 ಇದೆ, ಇಲ್ಲಿ ಎ ಇದೆ. ಸೊ ಇಫ್ ಇಟ್ ಆಲ್ ವಿ ಆ್ಯಡ್ ಫಾರ್ ಅ ಸೊಲ್ಯೂಷನ್, ದಟ್ ಈಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರಿಪೇರ್ ಅ ಸೊಲ್ಯೂಷನ್. ಯಾವ ಥರ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಿ ಅಂದರೆ, ದೆರ್ ಇಸ್ ಅ ಬಿ, ಹೌದಾ, ಇದಕ್ಕೆ ಸ್ವಲ್ಪ ಎ ಹಾಕಿದರೆ ಎ ಆಲ್ಸೋ ಗೆಟ್ಸ್ ಇವ್ಯಾಪ್ರೇಟೆಡ್, ಬಿ ಆಲ್ಸೋ ಗೆಟ್ಸ್ ಇವ್ಯಾಪ್ರೇಟೆಡ್. ಸೊ ಟೋಟಲ್ ಪ್ರೆಷರ್ ವಿಲ್ ಬಿ ಲೆಸ್ ದ್ಯಾನ್ ದ್ಯಾಟ್ ಆಫ್ ಪಿ ನಾಟ್ ಬಿ. ಯಾಕೆಂದರೆ ಬಿ ಈಸ್ ಮೋರ್ ವೊಲಟೈಲ್, ಇದಕ್ಕೆ ಲೆಸ್ ವೊಲಟೈಲ್ ಇರುವಂಥ ಎಯನ್ನು ಹಾಕಿದರೆ ಪ್ರೆಷರ್ ವಿಲ್ ಬಿ ಸಮ್ವಾಟ್ ಲೆಸ್, ದ ಟೋಟಲ್ ಪ್ರೆಷರ್ ವಿಲ್ ಬಿ ಲೆಸ್. ಸೊ ಅದಕ್ಕೆ ನಾವು ಇನ್ನೂ ಜಾಸ್ತಿ ಎಯನ್ನು ಹಾಕಿದರೆ ದ ಅಮೌಂಟ್ ಆಫ್ ವೇಪರ್ ಫಾರ್ಮ್ಡ್ ವಿಲ್ ಕಂಟೈನ್ ಬೋತ್ ಎ ಆ್ಯಂಡ್ ಬಿ. ಜಾಸ್ತಿ ಹಾಕಿದಾಗ ಎ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಜಾಸ್ತಿ ಆಗ್ತದೆ, ಬಿ ವಿಲ್ ಬಿ ಲಿಟಲ್ ಲೆಸ್, ಯಾಕಂದರೆ ಬಿ ಕಂಟೆಂಟ್ ವಿಲ್ ಬಿ ಲೆಸ್. ಆವಾಗ ವೇಪರ್ ಪ್ರೆಷರ್ ವಿಲ್ ಬಿ ಸ್ಟಿಲ್ ಲೆಸ್. ಸೊ ದಿಸ್ indicates the partial vapor pressure of B, which is equal to P naught B into XB. ಅದೇ ಥರ ದಿಸ್ ಗ್ರಾಫ್ ಇಲ್ಲಿ XA is equal to 0 ಅಂದರೆ ಇದರದ್ದು ಪಾರ್ಷಿಯಲ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಈಸ್ 0 ಅಂತ ಹೇಳ್ತೀವಿ, ಹೌದಾ. ಸೊ ಇದಕ್ಕೆ ನಾವು ಬಿಯನ್ನು ಹಾಕ್ತಾ ಹೋದರೆ ಫಾರ್ ದ್ಯಾಟ್ ದ ವೇಪರ್ ಪ್ರೆಷರ್ ಗೋಸ್ ಆನ್ increasing, thereby this graph will be like this. If at all we add sum of the partial vapor pressures, so ಈ ಪಾಯಿಂಟ್ ಎರಡನ್ನು ಸೇರಿಸಿದರೆ ಸೊ ಇದಕ್ಕೆ ಇನ್ನೂ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಬರಬೇಕು. ಸೊ ದಿಸ್ ಈಸ್ ಟೋಟಲ್ ಪ್ರೆಷರ್ ವೆನ್ ಎವರ್ ಅ ಮಿಕ್ಸ್ಚರ್ ಕಂಟೈನಿಂಗ್ ಬೋತ್ ಎ ಆ್ಯಂಡ್ ಬಿ ಆಟ್ ದಿಸ್ ಪಾಯಿಂಟ್. ಸೊ ಈ ಪಾಯಿಂಟಿಗೆ ಬಂದರೆ ವಿ ಫೈಂಡ್ ದ ಟೋಟಲ್ ಪ್ರೆಷರ್, ಇಲ್ಲಿಂದ ಇನ್ನು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಬರಬೇಕು. ಸೊ ದಿಸ್ ಈಸ್ ಅ ನೇಚರ್ ಆಫ್ ಗ್ರಾಫ್ ಫಾರ್ ದ ಟೋಟಲ್ ಪ್ರೆಷರ್. ದೇರ್ ಬೈ ದಿಸ್ ಗ್ರಾಫ್ ಆ್ಯಕ್ಚುಲಿ ಇದು 0ದಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗಬೇಕು. So it represents partial vapor pressure of B, whereas this graph represents partial vapor pressure of A, and this represents the total pressure, which is equal to partial vapor pressure of A plus partial vapor pressure of B. They can ask you to draw the graph for the solution containing A and B, and here we are going to consider the ideal condition. So this is the graph for ideal solution. It is the graph for ideal solution. Okay, so the graph of PA or PB versus mole fractions A and B for the solution gives a linear plot. Just now we have seen. Similarly, the plot of P total versus XA is a linear. ಈ ಥರ ಬಂದದನ್ನು ನೋಡಿದ್ರಿ. The minimum value of P total is P naught A and maximum value is P naught B. Assuming that component A is less volatile than component B. At equilibrium, the vapor phase, ಮೇಲ್ಗಡೆ vapor ಬಂದಿದ್ದು, it will be always in a component which is more volatile. So in the above case we find always at the equilibrium B will be more. If at all we want to see the composition of the vapor phase, so then it is determined by the partial pressures of the components. So in the vapor phase the mole fractions are considered as YA and YB. So YA and YB are the mole fractions of the components A and B respectively in the vapor phase. Then PA is equal to YA into P total, PB is equal to YB into P total. In general we can write PI is equal to YI into P total anta baritave. This derivation is not there, but based on this they can ask you to solve the problems. Okay, so the next one, we know that According to Raoult's law for liquid mixture, Pa is equal to P naught A into Xa. According to Henry's law, gas in a liquid, P is equal to Kh into X. So ಇವೆರಡನ್ನು ಕಂಪೇರ್ ಮಾಡಿದರೆ ನಾವೇನು ಹೇಳ್ಬೋದು, Kh when it becomes equal to P naught A, the two laws are one and the same. ಹೌದಿಲ್ಲ? So all the components are same, only they differ in the constant Kh and Pa. So by comparing the two laws, partial vapor pressures of volatile component or a gas is directly proportional to its mole fraction in the solution. Only Kh differs from P naught A. Thus we say that Raoult's law is a special case of Henry's law, in which yawaga Kh when it becomes equal to P naught A. Henry's law, Raoult's law ಎರಡು ಒಂದೇ. ಯಾವಾಗ Kh is equal to P naught A ಇತ್ತು ಅಂದರೆ we say that the Raoult's law is a special case of Henry's law ಅಂತ ಹೇಳ್ತೀವಿ. Okay, so in this what they can ask you, they will ask you the statement of the Raoult's law for volatile liquid. ಇದನ್ನು ನಿಮಗೆ ಯೂಶ್ವಲಿ 1 ಮಾರ್ಕಿಗೆ ಕೇಳ್ತಾರೆ. Next they will ask you mainly the problems based on any one of these form. P total is equal to P naught A into Xa plus P naught B into Xb ಈ ಫಾರ್ಮಲ್ಲಿ ಕೇಳ್ಬೋದು, ಅಥವಾ P naught A is equal to P naught B minus P naught A into Xb, or P total is equal to P naught A minus P naught B into Xa plus P naught B. ಇಲ್ಲಿ ನಿಮ್ಗೆ ಏನು ಕೊಟ್ಟಿರ್ತಾರೆ ಅಂದರೆ, they will give the vapor pressure in the pure form A, B ಕೊಟ್ಟಿರ್ಬೋದು. Instead of this Xa or Xb, they will give you the mass of A and name of the compound. ನೀವು ಆವಾಗ ಏನು ಮಾಡಬೇಕು, ಫಸ್ಟು ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಕಂಡು ಹಿಡಿದಾದ್ಮೇಲೆ ಯು ವಿಲ್ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ ವಾಟ್ ಈಸ್ ದ ಮೋಲ್ ಫ್ರ್ಯಾಕ್ಷನ್. ಸೊ ದೆನ್ ಯು ವಿಲ್ ಹ್ಯಾವ್ ಟು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಇನ್ ಆರ್ಡರ್ ಟು ಫೈಂಡ್ ದ ಟೋಟಲ್ ಪ್ರೆಷರ್. ಕೆಲವೊಮ್ಮೆ ಏನು ಕೊಟ್ಟಿರ್ತಾರೆ ಅಂದರೆ ಟೋಟಲ್ ಪ್ರೆಷರ್ ಕೊಡ್ತಾರೆ, ಮಾಸ್ ಆ್ಯಂಡ್ ನೇಮ್ ಆಫ್ ದ ಕಂಪೋನೆಂಟ್ ವಿಲ್ ಬಿ ಗಿವನ್, ಆ್ಯಂಡ್ ಒನ್ ಆಫ್ ದ ಕಂಪೋನೆಂಟದ್ದು ಪ್ಯೂರ್ ಫಾರ್ಮದ್ದು ವೇಪರ್ ಪ್ರೆಷರ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಯು ವಿಲ್ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ಅದರ್ ಕಂಪೋನೆಂಟ್. ಈ ಥರದ ಪ್ರಾಬ್ಲಮ್ಸು ಸಿ ಇ ಟಿ ಅಥವಾ ಬೋರ್ಡ್ ಎಕ್ಸಾಮಲ್ಲಿ ನಿಮಗೆ ಯೂಶ್ವಲಿ ಕೇಳ್ತಾರೆ. ದೇ ವಿಲ್ ಆಸ್ಕ್ ಯು ಟು ಡ್ರಾ ದ ಗ್ರಾಫ್ ಆಫ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಅಗೇನ್ಸ್ಟ್ ಮೋಲ್ ಫ್ರ್ಯಾಕ್ಷನ್ ಫಾರ್ ಆ್ಯನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್. ನಾವು ಶಾರ್ಟ್ಲಿ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ವಾಟ್ ಈಸ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್. ಇದ್ರ ಮೇಲಿಂದು ನಿಮ್ಗೇನು ಕೇಳ್ತಾರೆ, ಗ್ರಾಫನ್ನು ತೆಗಿಲಿಕ್ಕೆ ಕೇಳ್ತಾರೆ. ಸೊ ದ್ಯಾಟ್ ವಿಲ್ ಬಿ ಆಸ್ಕ್ ಫಾರ್ 1 ಮಾರ್ಕ್. ಓಕೆ, ಸೊ ಮತ್ತು they will ask you the problems based on this equation, that is they will ask you to calculate the composition of A or B, ಅಥವಾ ಯಾವುದೇ ಎರಡು ಕಂಪೋನೆಂಟ್ ಕೊಟ್ಟಿರ್ತಾರೆ. they can ask you to find out the composition in the vapor phase. ಟೋಟಲ್ ಪ್ರೆಷರ್ ಕೊಟ್ಟಿರ್ತಾರೆ, sometimes they will give you the partial pressure, ಅಥವಾ ನಿಮ್ಗೇನು ಕೊಟ್ಟಿರ್ತಾರೆ ಅಲ್ಲಿ the vapor pressure in the pure form ಕೊಟ್ಟಿರ್ತಾರೆ. So by using this equation you will have to find out Pa is equal to P naught A into Xa. ಅದನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಿಬಿಟ್ಟು ಯು ವಿಲ್ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ PA, ದೆನ್ ಟೋಟಲ್ ಪ್ರೆಷರ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ, ದೆನ್ ಯು ವಿಲ್ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮೋಲ್ ಫ್ರ್ಯಾಕ್ಷನ್ ಇನ್ ದ ವೇಪರ್ ಫೇಸ್. ಈ ಥರದ್ದು ಮೇನ್ಲಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ವಿಲ್ ಬಿ ಆಸ್ಕ್ಡ್ ಬೇಸ್ಡ್ ಆನ್ ದಿಸ್ Raoult's law. ರೇರ್ಲಿ ದೇ ಕ್ಯಾನ್ ಆಸ್ಕ್ ಯು ಟು justify the Raoult's law is a special case of Henry's law. ಆವಾಗ ನೀವು ಇದೇ 2 ಸೆಂಟೆನ್ಸ್ ಬರೀಬೇಕು. Okay, so in the next video we will solve some problems based on Raoult's law.